Hello guys, how are you? Welcome to the last class of matrices and determinants. Last lesson we talked about the inverse of a matrix and how we can prove that if B is the inverse matrix of A, so the multiplication or the product of A times B equals to the identity matrix. So if we have been given two matrices and we are asked to find the inverse of A, which is B, we can multiply A by B and B by A. If the answer is the identity matrix, so we would say B is the inverse matrix of A. We also talked about the determinant of a matrix of order 2 by 2. If we have an A which is 2 by 2 matrix, we can find the determinant of A by just multiplying the diagonal elements minus the other elements. We call this the determinant of A. Why do we need this? We need the determinant to find the inverse of the matrix A. And we said if we want to find the inverse of a matrix 2 by 2, we can define A negative 1 equals to 1 over the determinant of A multiplied by this matrix. This matrix is defined by just switching the diagonal elements, multiplying the other elements by negative 1. So basically we have to find the determinant multiplying this by this matrix. So we can find the inverse of a matrix 2 by 2. And we have this question, how to find an inverse for a 3 times 3 matrix. So today we will talk about how to find the inverse of 3 multiplied by 3 matrix. Let's take and consider this example. A is defined by 3 times 3 matrix, and we are asked to find the inverse of this matrix. So the first step, as usual, we have to find the determinant of A. So the determinant of A, by definition, we can take one row or one column, and we can find the determinant by this formula. Take the first element multiplied by the subdeterminant of this element. You cross this row and this column, you find the determinant. You switch the sign minus the second element multiplied by the subdeterminant of this matrix, which is 1, 2, 7, 8, plus 9 multiplied by the subdeterminant of 9, which is 1, 2, 4, 5. We do the calculations and we get the determinant of this matrix. Guys, just in case the determinant of A equals to 0, we would say this matrix has no inverse, so we cannot find the inverse of this matrix. Let's say we found the determinant of this A. It's not enough, we have to find another things. We have to find the cofactor matrix of A. How? By definition, we can define the cofactor for each element of matrix A as the subdeterminant of this element. For example, let's take this 1. We would say the determinant for this one is 4, 5, 0, 6. For A12, it's negative 0, 5, 1, 6. For A13, we have the subdeterminant. So and so on. We find all these determinants. Once we have them all, we can define the cofactor matrix as all of these elements. And we would write cofactor matrix of A is then given by the determinants of its elements. So again, what we did is the first step we found the determinant of A. The second step we found the cofactors of each element of A. So in this case we have 9 elements, 9 factors, and we define the cofactor matrix with these cofactors, with these elements, with these numbers, and then the last step we have to find the inverse of this matrix. How to find the inverse matrix of this 3 times 3 matrix? We can define A negative 1 equals 1 over the determinant multiplied by or times the transpose of the cofactor matrix. Again, 1 over the determinant of A times cofactors, but we take the transpose of this matrix and then we find the answer. The answer is going to be 3 times 3 matrix. We will get A negative 1. So basically it's more than one step. First step we have to find the determinant. The second step we have to find the cofactors of this matrix. We have to take the transpose of this matrix and then multiply this coefficient by this matrix to get the inverse matrix of A. So basically we have two types of matrix. Let me say two examples: 2 by 2 matrix and 3 by 3 matrix. To find the inverse of the 2 by 2 matrix, immediately and easy way, we can just find the determinant multiplied by the new matrix. But for 3 multiplied by 3 matrix, we have to follow some steps to find the inverse. So we can define and we can find the inverse of a matrix. Thank you guys.